Okay, so welcome everyone. We're going to be starting our 7th, 8th meetup of the year. Can't remember now. We've been doing a lot of this lately. So this is going to be our second international event. We are full of international guests here. And as usual, remember to follow us on the social medias of Python Bucaramanga. You can see them down below on Twitter, on Facebook, on Instagram, on LinkedIn, and we also have a chat on Telegram. You can also be part of the Python Colombia community, which groups all the different communities working with Python and technology in Colombia. So we're going to follow as usual. So hi, my name is Gonzalo. We'll try to start 5 minutes after the hour while we have our guest arrive to the meeting. And well, we'll just wait for a little bit. So maybe we can start by just presenting everyone and tell us where you are. So I'm in Bogota, Colombia at the moment. It's pretty cloudy, not super hot. So yeah, I don't know. Tell us something about you. Mafe, why don't you go?
Hi guys, nice to meet you. My name is Mafe Toro. I am from Bucaramanga. So I am part of this amazing and really nice community, Python Bucaramanga. So we are very happy and excited to be here with you guys. Thank you so much, Victor, Taras, Priyanshi. That's correct? I don't know, sorry, I apologize, it's not correct.
No,
Yeah.
it's okay, it's Priyanshi.
Priyanshi. So we are really, really happy and excited to this second meetup in English. So that is really cool for our community. We want to Colombia be a really, really good country with this IT technology. We can grow out, and the most important, we can keep practicing English because we need to in this career, right? So it's my pleasure to be here. Thank you so much for your time, guys. I don't know. What do you think, Paris? I want to know more about you.
Yes. Hello, everyone. My name is Taras. I'm from Ukraine, and it's typical autumn right now in Ukraine. And yep. So, thank you so much for invitation. Yep. Nice to meet you all.
Cool.
Yeah, thanks, Gonzalo. Maybe I can go next. Yeah, so based in France as well, autumn there starting, so and 6 o'clock in our time zone. So actually, yeah, so we actually spread out on the different time zones. So it's morning in like afternoon in your time zone. Priyanshi is in India, so it's like the tonight almost, and like 6 o'clock in France and 7 at Ukraine, right, Taras? Yeah, excited to be here in this meetup and spread some words about PyTorch-Ignite and what technology we are doing.
Awesome. Priyanshi.
Yeah, so like Victor said, it's like night here, like 9:30 in the night here. Yeah, I'm Priyanshi, I'm from India, and thank you for having us. I hope you all learned like something new today, and yeah.
So yeah, for this event thanks all for you for coming. So this event is going to be also a new event, like we have all here, like core developers of PyTorch-Ignite. So Victor asked me to bring other guests so that we can talk about the things. And I would like to apologize to our guests because we had this little last minute change and we didn't get your information on all the flyers and the publicity that we did on social media. We'll try to fix that after the event. But we are super thrilled to have a bunch of people here on our meetup. So I guess it's almost, what time is it? It's over 5. We can wait a few more minutes just to come. Plus, if you just joined the event from wherever you are, just leave us a comment. If you're from YouTube or watching us on Facebook, just leave a comment on the comment section. Where are you watching us from? If you have any issues, as usual, with the font size might be too small, or we need to increase something, or there are some audio problems, just let us know through the chat, and we'll try to fix everything while we start. So let's just give it a couple of more minutes. We have around 10 attendees at this moment. This is a very specific topic. Being an English meetup, we might have not as much of an audience as we would like to, but this is part of trying to motivate more people to participate in these events. This event will be recorded on YouTube, so if you cannot make it because you are doing something on your weekend, just remember that you can watch this afterwards, so it should not be a problem. So I think we are ready to start. I think we can go right now. So let me just put your presentation here. Yeah, I mean, Tash, Priyanshi, Victor, thanks for being here. We'll be with Mafe on the background trying to make things work. And in case connection goes down or whatever, we'll just try to figure it out during the way.
Sounds good. Sounds good.
Thanks.
Thanks, Gonzalo.
Enjoy, guys.
Cool, thanks. Right, so this is a presentation about PyTorch-Ignite, the library we are working on since several years for someone, several others, I mean, different times who joined when the project. And for those actually who is interested in the slides, we have deployed them in this URL. Actually, can you see my mouse here or not moving?
Yes, we can see your mouse, and we will be sharing the link that you share. We'll share it on the comments.
Great, great. Okay, so we'll start probably in the beginning with presenting ourselves, introducing. So I'm Victor. I'm a software engineer at one side working on AI-related open source project as PyTorch, Torch Vision, and PyTorch-Ignite as well. Yeah, so maybe Prancy, if you'd like to go next.
Yeah, hi everyone, I'm a CS undergrad, and I joined PyTorch-Ignite, working on its docs as part of Google season of docs. I'm also managing the community. Yeah.
Hi everyone, I'm Taras. I'm open source enthusiast and biologist in the past, and currently I'm contributing to PyTorch-Ignite and its side projects. Thank you for having us.
Great. Right, so the content of this presentation will actually talk about these following parts. So for those who is a bit unfamiliar with what is PyTorch, so will be sort of small recap of what it is and how it's working, and in machine learning mostly, right? Then we'll speak about PyTorch-Ignite and give some motivation, argue why it's interesting to use it. Will be also quick start example using PyTorch-Ignite. A part how to convert pure PyTorch code to PyTorch-Ignite. I mean PyTorch plus Ignite technically. And finally, we'll just end up with a few. We'll give a context actually how this project actually works behind and as being an open source project. Right. So let me start with PyTorch itself. So just a quick introduction for those who is unfamiliar, as we probably can't assess that everyone knows this. So basically, it's a library, and library. It's a framework, and one of the popular and one of the most well-known and in open source community to do machine learning and deep learning. And so basically, it's sort of a tool or framework providing you tensor manipulation operations. So you can have tensors on CPU, on GPU, on TPU, and other different hardwares if it's supported. Plus, they also give some neural networks components, algorithms, how to do optimization, specific, probably most common loss functions to actually simplify your work if you do some machine learning or deep learning work. In addition to that, they also provide some cool features as distributed computation, profiling, and other things. There is also a rich ecosystem, some part of also managed by Facebook. So libraries like Torch Vision, text, audio to process images, text and audio. And there is, as I said, so there is a rich ecosystem where different kinds of helper tools, libraries, frameworks also working with PyTorch there. Okay, so really quick introduction to PyTorch while we're doing machine learning in 3 slides. So basically think of the following. So let's say we have a computer vision task where we'd like to classify some images. And we would like to build a model and train it such that it can predict, for example, given an image, it can predict some labels, which can be associated with some context. For example, if we give an image of t-shirt, so it gives us 0, and which is associated with a t-shirt. Same for dresses, coats, etc. So actually this data set is called this fashion list. So technically what we'd like to do with machine learning with PyTorch is to bring some model that we feed up, and we give an image, gives an image, and then it predicts some label. We train it such that actually it predicts something something meaningful, and then we also like to measure actually this model performances, at least. So the code with PyTorch looks like that, this following. So technically, the first part is that we set up some training and testing data. Here we use Torch Vision as a computer vision domain library. So here it brings us a fashionist. We wrap up this data to what PyTorch calls as data loaders. It means actually we just make images together, put them together in a certain batch. For example, 64 images together. And data loader actually gives us some batches. For example, like here we have 64 images of actually fashionistas, just gray level images of 28 by 28. And we have a vector of targets, actually the labels associated with these images. And so what we'd like to do is to have a model, as I said. So we create a model which will classify these images. So PyTorch brings these neural network components out of the box. And for example, here we can build a neural network based on fully connected layers, where we just flatten the image into a vector and processes to a vector of size 10. And as you see, so PyTorch also can work on GPUs, for example. So here, if you have a GPU, so the model will be instantiated, the weights and everything will happen on GPU. While we're training the model, so we'd like to optimize the following problem. So we have a model that is working on images. It predicts some labels. We can compute can compute errors, right? So how predictions are different from the targets. And here is a typical code for PyTorch where you training the model in the following way. So you have a you pass the train loader, actually training data, and we loop over the training data multiple times, which is called epochs. So here we have just 5 epochs, so it means that we loop over the training data 5 times. And during each loops, in the train method, we compute the predictions, we compute the errors, and backpropagate using a stochastic gradient descent algorithm. And such that we optimize the parameters, well, update the parameters such that the error is minimized. And after each epoch, we'd like to measure some average loss, for example, average error or accuracy. So this is a brief introduction to PyTorch and how we can quick start, how can we do machine learning work with PyTorch. Right, so then the question, well, here we're talking about PyTorch-Ignite, so why using PyTorch without Ignite is suboptimal? Technically, if we just focus on tasks for neural network training and evaluation, we can say that PyTorch brings only low-level components, even if, for example, those components which they bring is already high-level in a certain way, that how it works on CPU, how GPU. But for tasks for training neural networks, we can say that this is sort of low-level, and this can be seen especially when you have, for example, user project where you have to evaluate your model and then you will write your metrics every time. For the training pipeline, like checkpointing, saving best models, early stopping if you'd like to have it in your training pipeline. So all the things you will write every time on the project. And certain way, PyTorch doesn't provide these things due to as being generic. And this is, I would say, more related to some specific problematics. And this is where actually PyTorch shines, so PyTorch-Ignite shines. So here again, so the pure PyTorch code, as I've shown in the fashionist example. So we have some basic ingredients for model, data, optimizer, optimization algorithm, criterion, and all the things actually we have to write in PyTorch. So for example, this code is responsible for computing accuracy metric. So this code you will probably have to factorize and go put it somewhere in a common place such that you can use it every time in your different projects. These methods are not implemented, but such method actually also will be have to be written by the user. And we have, so again, these two loops where we make a loop on epochs, on data. We bring some logic how to update the model, and here is the pipeline, training pipeline logic. So with some frequency, we'd like to validate the model, save best model, and make some checkpoints during the training. If, for example, imagine your training crashes and you'd like to continue training instead of starting from the beginning, so that's why you'd like to probably do some checkpoints. So all this code actually a bit I would say verbose, and this is where PyTorch-Ignite can help. So PyTorch-Ignite actually, it's a sort of high level, in this case, library which simplify the training and evaluation of the neural networks with PyTorch in a flexible and transparent way. And then it's an open source project. If you're not familiar, so you can find it here. And what PyTorch-Ignite brings is 4 types of components, I would say. So the first one is the engine and event system, which the idea of this design is to simplify and actually make the loops abstraction, so training loop abstraction and evaluation loop abstraction. In addition, also we provide the out-of-the-box metrics, built-in handlers to actually compose your training pipeline. And the fourth component is how to make distributed training easy. Okay, so maybe a question you can have if you're already familiar with PyTorch and its ecosystem. So what makes PyTorch-Ignite unique? Here we can answer that in these 3 points, that the PyTorch-Ignite by design actually provides composable components such that actually you can construct and build your training pipeline yourself. So here you can think about the difference between library versus framework, right? In framework, you already have some building, and then you just fill up the empty room or empty holes actually, such that you just fill these empty things, and then everything works. And the library on the other side, sorry, so it can just you compose this building and bring with these tools brought by the library, you compose things. In a framework, the problem can be that if you have some specific use case that framework wasn't designed to support this use case, so you can have a limitation, and then probably you won't be able to use it. On the other hand, library, you don't have any simplified, already like one-line simplified code, but you have to build your training pipeline. But in this case, you have a possibility, actually you have this flexibility to cover your use case in this case. And yeah, right. The second point, which makes also PyTorch-Ignite unique, is the simple understandable code. If you take a look on our GitHub, so it's rather simple code behind. And the third point, which we'll talk a bit more, it's about our open source community involvement. Right, and how PyTorch makes our life easier. So technically, you'll have less code than pure PyTorch to do. And our point is that we also ensure the maximum control and simplicity. So the idea is not to simplify and hide every code of PyTorch, pure PyTorch, just in a single line, but hide it such that you can still compose things and still have a possibility to make your any kind of researchy thing, and without being blocked actually by the library itself. Second part is that you can easily get more refactored code and have more structure there. You'll see probably in our examples. Yeah, so we provide also metrics, handlers, such that you can build quickly your training pipeline. And we also make provide the bricks actually to make your code the same code for distributed and non-distributed configuration. Right, so now Taras will talk about a quick start example and present you in details how PyTorch works on MNIST classifier.
Thanks, Victor, for the awesome introduction. So, Taras, the stage is yours.
Yes.
Enjoy.
Great. Let's get our hands dirty. Now you know some PyTorch and PyTorch-Ignite basics. You know what are they in a nutshell. So let's use them in practice. In this quick start example, we will train a simple MNIST classifier. You probably heard about MNIST. It's an image dataset with thousands of handwritten digits examples. And you can think of it as a hello world dataset for deep learning and computer vision tasks. Yeah, so let's get started. First thing first, there are some prerequisites. We have to install PyTorch. And in addition, PyTorch provides some additional libraries for specific tasks. And in this tutorial, we will use one of them called Torch Vision. This package contains datasets like MNIST that we already mentioned, some image models, and other helpers to start and to work with computer vision tasks. Okay, after that, you have to install PyTorch-Ignite. You can use pip with this command or conda with this one. If you need more options like Docker images, so please visit our GitHub or our website for more information. We have a couple of pre-baked Docker images for different tasks. So yeah, so feel free to take a look. Yeah, after we installed all the packages, so we have to import all the necessary things. So we start from importing PyTorch related stuff. We import neural networks, NN module. We import data loader, and from Torch Vision, we import MNIST dataset, some required transforms, and of course a model. In this tutorial, we will be using a model with ResNet 18 architecture. So it's pretty simple, but it's enough for MNIST. Okay. Yeah. So the following block of imports, it's all about Ignite. We import some helpers from engine module, some metrics like accuracy and loss. We'll talk about it later. And two handlers, one for model checkpoint and another one for experiment tracking with Tensorboard. Great. Yeah. So now we are ready to do some coding. Usually we start from PyTorch part. So first of all, we define our data flow, create data loaders. Note that we have two of them, one for training and one for validation. After that, yeah, we are ready to define a model. It's pretty simple. We have only 10 classes, and it utilizes a ResNet 18 backbone, as we already mentioned. We just need to tweak the first and the last layers of the model to get it work. Yeah, and we set device to CUDA to speed things up. If you don't have GPU, you can use CPU, of course. And then we instantiate a model and move it to GPU. There are two more things, an optimizer and loss function. We can train a model actually without them. So we specify them here like that. Yeah, and now we are done with PyTorch part. Yeah, and we are ready to work with Ignite. We already defined it, data loaders, optimizer, and loss function, and now we need to stick them together and to get a training pipeline. So that's time the right place to use Ignite. And first of all, we have to define two engines. The first one is called trainer, that will be used for training, and the second one will be evaluator, that will validate a model on that test part of dataset using test data loader that we mentioned before. It will compute the metrics and save the best models. In this particular tutorial, we will use create supervised trainer and create supervised evaluator helpers from engine modules. It's like the quickest way to get started with Ignite. So if you need more control, so you can use engine class. We will talk about this later. You will see that there are many options for that. Yeah, could you please the previous slide? The difference that you might notice that we pass to create supervised trainer helper, we pass a model optimizer and criterion, and to evaluator we pass just a model and a dictionary of the metrics that we want to compute and actually to store the best model. Okay, so we are ready to go to the next slide. And so currently we have a model, but we have no information about what is happening. So let's add some loggers and to make the training pipeline more complicated and more verbose. So in this, so we're going to add two of them. One of it will be called log training loss, and it will print to standard out some information like current epoch, the iteration, and the loss, the batch loss. And then we're using some synthetic sugars with decorators, how to attach this handler to an engine. In our case, it's trainer. We'll talk about this in the next section. There are alternative way to do that. And as you can see, this handler will be triggered on every 100th iteration. All right. So, yeah. Another handler that we will be using called log validation results. So we attached it very simple in similar way using decorator, but instead of previous one, it triggers at the end of each training epoch. And what is interesting, as you can see, the first line of log validation result, it will trigger the run of the evaluator. So the validation step will be triggered by this handler. And after that, we are ready to print some, to compute some metric. Actually, the evaluator will compute all the metrics, and then we can extract them via state, and we are ready to print it to standard out. So let's add another handler called model checkpoint. We attached it in slightly different way using add event handler. It's another way how to add it, and you see it will trigger it when epoch is completed, when validation epoch is completed. And we specified a number of best models to save into 2. So, and the score function that will be used for rating will be accuracy. We specify like here, right? And yeah, so the evaluator will trigger model checkpoint handler on each epoch, and two best models with the best accuracy will be stored to the drive. Okay, and the last thing that we want to add is a Tensorboard Logger. Very often printing results to standard out is not the optimal solution, right? And one of the best practices actually use some experiment tracking system. So in this case, we will use the Tensorboard Logger for tracking, and PyTorch-Ignite provides a handler for it. So we're doing like similarly like we have for model checkpoint. So we specify it here, and then we attach the logger to the trainer to log training loss at each 100 iteration. And after that, we attach a logger to the evaluator to log all the metrics. Yeah, we specify all metrics at every epoch. And so we will log accuracy and the loss. Okay, so finally, we start the engine run on the training dataset and run it for 5 epochs. And now you can monitor the training process. And yeah, so engine, trainer, in our case, it will runs and triggers events, and then all the handlers and functions that we defined and attached to the engine will be triggered on that specified events. So that's actually the beauty of the PyTorch-Ignite. Yes. So after 5 epoch, you'll see that we reached a good results, I would say. Yeah. So we can also take a look at Tensorboard right now, and you see that we have 3 plots as we planned, like as we set up. The upper one for training part. We see the batch loss monitoring, and here, and below we see 2 plots with accuracy increasing. So that's great news, and with validation loss here. Yeah, great. Yeah, so the notebook with complete code with explanation is available here on our website, and actually it's a rendered version, and you can open it with Collab using this link, and you can go through it and try it by yourself. Yeah, the last thing but not least that I wanted to mention is our app called PyTorch-Ignite Code Generator. So basically, it's a application with a web interface that provides you a user interface with options that you can manipulate all the parameters of the training pipeline. For example, handlers, models. So you can select it from the list and choose that one that you wanted, and the app will generate all the training code for you. So this is actually also a very good way to get started. As you can see on the demo, there are a couple of templates there. Currently, we have for classification, vision classification, for object detection, for segmentation. So we can start with one of them, and then you can configure it using UI, and as a result, you can download all the generated files as a archive, or you can just jump into Colab notebook and start working with this. Okay. If you have any questions about quick start example, or maybe about PyTorch-Ignite in general, so yeah, do not hesitate to ask them right now. Okay, so I think we can continue, right?
Yes, no, so far we don't have questions, so
Okay.
please continue. Thanks, Derek.
Right.
Okay, there is one question from Diego, and he's asking, are there different algorithms for minimizing cost functions?
If I got it right, we do not provide any some sort of optimizers, because it's actually
yeah, I mean, it's Torch, it's PyTorch.
Yes.
I mean, work, I would say. So yeah, there are different algorithms for minimizing. I mean, it's well, all of them based on stochastic gradient descent, right? So it's SGD, and then there are different flavors of it. And PyTorch-Ignite is more about how to simplify the training without actually altering the way how you would like to optimize things. So if you have some already pre-baked optimizer, you just plug in and it should work.
Yeah, exactly.
Yeah, if it respects the same logic as PyTorch has. Okay, so let's maybe continue with the big picture of what PyTorch-Ignite does, and maybe things become more clear.
Okay, so the big picture of PyTorch-Ignite is the following. As we already mentioned, it is built on top of PyTorch, and you can see the following modules, like engine, distributed. It's, I would say, the core, the main modules of the library. And here you can see engine and state classes that also like the core entity, I would say, of the library. On top of that, we have handlers and metrics. There are a lot of handlers. For example, like early stopping for timing and checkpointing and scheduling. We also provide a lot of experiment tracking systems. Handlers for experiment tracking systems. And you can use handlers with, you actually use handlers with engine. They work with engine. Metrics also works with engine, but you also can use it like independently. We'll talk about this later. And yeah, there are a lot of metrics there. There are for classification, for regression, and for GAN, for NLP. So yeah, and another very important module is distributed, that actually helps you to set up to build the distributed setup. Yeah, using like different backends and tools. Yeah, so as we already mentioned a couple of times, that engine and event system is the central entity of the whole library. And here on the right, you can see its simplified representation. So engine loops over the data, over the user data. It processes the batch and fires the events. And there are a collection of built-in events, of course, but you're not limited to them. And so basically, engine is a very smart abstraction over a training loop. Okay, and this design actually helps to simplify training pipeline development. So, yeah, on this example, we have a training step. So by using this design, the user just have to define a training step describing how to process the batch, how to compute the loss, how to upgrade the gradient, how to compute the gradients, and how to update the weights. And so user like doesn't think about how to write training and evaluation loops, thinking about switching the context of the model. So by using this design, user focus on iteration rather than on the whole loop. And on this this is on this example we create a train step that describes how to process the batch, and we attach it to the trainer. Later using add event handler. So we already seen this when we attached the Tensorboard Logger and the model checkpoint. And another way how to create an engine instance is to use create supervised evaluator, like we did in quick start example. So this helper actually provides this function that process the batch for you. But if you want to have something specific, if your task is not supervised, it's not a supervision task, so you can you have to define your own train step, like in this example, and pass it to engine class and create a trainer instance like that. Yeah, so you see that there are like two things how to do that, to attach with add event handler, or by using decorator. So we already seen this before. Okay, we can go next. In addition to already described simplification, this design actually allows us to execute any number of functions and handlers, and moreover, these handlers actually can be anything. So it can be a regular plain functions, it can be lambda functions, even class methods. So, for example, in this for example, we use just a lambda function, and we attached it directly to be triggered when the epoch started, when the training started, actually. And we print to standard out like some information like training has started. And and on the next example is just a plain Python function, so you can convert it to use it actually as a handler, and printing some info. Actually, like we already we already did it in a quick start example, so you are familiar with that. Yeah, and on the next, as I already mentioned, that you can call any number of functions like on a single event. So this is really cool. Yeah, I think we can go next. And another cool feature is that PyTorch-Ignite has built-in events filtering and stacking. For example, the first function titled run validation will be run every 5 epoch. So you attach it to trainer, and you specify using events, like epoch completed every 5, and we will trigger it every 5 epoch. And I've imagined that you want to run it like every 5 or 10 epoch, and you want to run it when the training has finished or just started, like on the first epoch or on the last epoch. And you can combine it using in this way, like using 2 different events and combining it with this pipe. Okay, and now this example actually shows explains the situation when like you want to run to trigger the handler once and only once, and at particular a number at particular event. So here we will trigger this change training variable only once on 20th epoch. So this is so you are not limited just to that. So you just need to specify this particular argument once and it should work. Okay. You can also use a customly defined function that filters the events. If you want more, like if you have some like very complex training pipeline, or you want something really specific, so you can create your own custom event filter function defining how frequently execute this handler. And okay, we can move next. Okay, the last thing that you can define your own custom events. If the built-in collection of events are not enough for your problem, you can define your own events, and you can do it in this way, like we have in this example. We are going to create some events related to backward pass. So we use event.enum, and we create we define new events like that, like you have here, like class back prop events. So we have a backward starter, backward completed, and optimizer completed. Then in train step, you have to specify that points when these events should be fired. So so here we use engine fire event and back prop started. Just write loss.backward just right before calling the backward pass, and doing the same thing for other events that we just created. After that, you create your trainer with engine step, as we already know, and then you have to actually register your custom events, to get it work. So you just use register events method, and you're ready to go. And just don't forget that you have to use when attaching, you have to use your just defined back prop events here. And you're ready to go. Okay, Victor, would you like to proceed on metrics? And
Yeah, sure. Thanks, Ross.
Great.
Right. So previously we see that, so the first abstraction we had, so engine in events, and you saw that, well, we have a lot of flexibility in how we construct engine, how we construct training step, the events that are really extensible and filtered rather quickly. The second point is about the metrics. So Ignite proposes out-of-the-box metrics with a large list of already pre-computed metrics for different deep learning tasks, for computer vision, NLP, GAN, etc. In addition to that, we have also, you can extend them. So if you have some particular metric to compute, you can just derive from the base metric in our class. Or if you have something that can be quickly expressed with a mathematical expression, for example, here, you can just compose it rather simply compose it like this. For example, here we have a precision metric built in from PyTorch-Ignite recall, and we would like to compute something like F1 per class. And yeah, so let's say it's this expression. Then we also can apply built-in torch methods on it. So here actually is sort of lazy evaluation, will be lazy evaluated by class. So this is just class, nothing is computed here. And once it is attached to the engine, an engine, for example, evaluator run on validation data. So finally, once everything is done, so we will have your F1 computed using this expression. This is something cool as well. Third point is about built-in handlers. So if you'd like to put some more logic in your training pipeline and without writing actually the logic. So for common tasks, we already have some handlers which can be easily added to your pipeline. For example, model checkpoint, as we saw in the quick start. So what it does actually is it just saves the model, for example, here, every 2 epochs. For example, if you'd like to stop your training according to some score, for example, accuracy, and imagine a situation where your training is progressing and now you start overfitting. So you'd like to stop your start your training because it doesn't make sense actually to continue, just waste the energy. So you have a pre-built PyTorch-Ignite handler for this. Learning rate scheduling. So here we add more flexible, I would say, parameter scheduling, optimizer parameter scheduling, in addition to what PyTorch provides. For example, here we have piecewise linear scheduling for learning rate, where we have something like warm up, and actually here it's just a linear descent, but we can imagine that we can have some warm up plus descent plus anything you'd like to do here. And we have a bunch of different types of schedulers for this. Support for common experiment tracking systems like Tensorboard, ClearML, Wisdom, Neptune, MLflow, and probably many more. Profiling handlers we also have. So there is a bunch of pre-built handlers which you can just plug into your training loop like this. And finally, distributed training support. So here the idea is that you could have the same code that could run on non-distributed and distributed configuration, supporting Torch native communication frameworks like Nickel, Glue, MPI, or Horvath, for example, or if you'd like to run on TPU using XLA. So technically you have the same code, and this code just specifying the backend, it will run on, specifying the backend, it will run either using Torch native Nickel distributed option, Glue. If you're using Horvath, so you specify Horvath, and everything will work for Horvath. If you're running on TPUs, so you specify it there. If you specify none, and you have only one GPU or CPU, so everything will be adapted. And in addition to that, we also provide some methods like auto data loader, auto math model, and auto optimizer to adapt actually the data loader model and optimizer to the specific configuration. Right. Maybe a bit more on that. So this code actually can be launched with either with a multiprocessing spawn. So it means that you have a single entry like Python main.py. You launch it like that, and then internally you spawn the processes, or either you can use Torch utils like Torch distributed launch, which actually roughly schedules end processes, and these end processes will run your script. If you use Horvath, so you can use Horvath run tool, and also we support Slurm. Right. So in addition, as I said, so we have also high-level helper methods to adapt your model, optimizer, and data loader. And the cool thing here is that actually you do not need to use these things if you have something more adapted to your use case. So for example, if you have something specific to your data loader that you do not want to, in our case, what it does actually is just use a distributed sampler for DDP, scales batch size, number of workers, and this it. But if you have something more tricky or more specific, you just skip this, you use your thing, but this thing you can still use. And everything is optional, but a helper function, as you see. In addition to that, also we provide some low-level ops, collective operations, like all reduce, all gather, broadcast, and everything works for specified configuration and supported by PyTorch-Ignite. Right, so if we have some questions on this part, so please ask. Otherwise, we can go with our next part. Okay, so if there is no questions, so let's go to how to convert pure PyTorch code to PyTorch-Ignite, PyTorch plus Ignite, actually. And Prancy, please go ahead. Gonzalo, can you put Prancy to the stage? Thanks.
Yes, sorry, I was
Right.
here. Okay, thanks for that.
We do have a question in the chat. What are the drawbacks of this flexibility? Yeah.
Good question. What are the drawbacks of this flexibility? I would say the probably major drawback in this is that you have to build your training pipeline yourself. So if you search for one-liner solution, probably in this way, PyTorch-Ignite won't help you with it because you have to put more code on that. So you have to write your code, say how you'd like to, code how you'd like to see your training pipeline. So in this way, probably PyTorch-Ignite won't help you to just hide everything in a single line. On the other hand, it gives you like the flexibility if you have some specific case and specific things, so you can encounter that in this design.
Okay, so I guess I'll continue from here. Okay, so let's see how we can translate pure PyTorch code to PyTorch-Ignite. If we move on, we'll see, so on the left side, you can see like we have pure PyTorch code. And if we go to the next slide, we'll see that configurations such as like your model, your data sets, your optimizer criterion, they will all remain the same since PyTorch, as we established, PyTorch is more, will help you more with like training and validation. And next, what we have to do is we have to identify where our training loop lies. When I say training loop, I mean the part where we are looping over our train data loader batch by batch. And inside this, we are putting the model in train mode. We are then doing a forward pass, we're generating outputs, we're calculating loss, we're doing back propagation, and you have to identify this part, and all of this logic under this training loop goes under trains, any function, let's call this train step, but this function should accept the engine and batch, or a batch of data as parameters, and then you all of the logic will be copied here, and this function can return anything that will like be helpful to you for post-processing. Let's just return loss here, and to make this into a trainer engine, we'll just wrap this function in engine, and there we go. And next, we will have to identify the validation loop or the validation logic in our PyTorch code. And when I mean that, we have to just identify where we are like looping over the validation loader batch by batch, and then generating predictions. So what we'll do here is we can either take this logic, and just like in the previous step we defined a train step function, we can define something as validate step and put the same logic here, or we can use the helper function create supervised evaluator, and this will essentially internally do the same thing inside, just loop over the val loader. And that is how we define an evaluator. Next, in PyTorch, we'll see if we have some metrics needed for evaluation, we have to write the custom code for it, and this makes it like uses a lot of like formulas and makes it really bulky. But all of this logic can be converted to just one line with Ignite's built-in metrics. Here we're going to just use accuracy and attach it to our evaluator. Next, we have to, now next, if you have something like this in your loop, something like this in your training loop where you are like if function, so this will only run like on validate every epochs. So an easy way to do this is just take all of the code, the logic, like here we are like calculating accuracy and printing them out. Take it all of this logic, put this under a function. Let's call this run and log evaluate validation. And what we do is we attach this function to the trainer with the help of a decorator, like we saw. And what this function, on the left side we have if epoch, if it has like validate every epoch, we convert this to this function will be executed after like validate every epoch. And inside the function, we just run the evaluator, we calculate our metrics, and we log them out. So and next, if you see on the left side, I don't think it will be visible, but we have a TQDM for tracking progress, and we can like convert this to just a simple progress bar handler. We attach this to a trainer. And in PyTorch, if you need to save your model optimizers, make a checkpoint, you have to write this custom code using torch.save. All of this can be converted to just the checkpoint handler, and the checkpoint handler can in the first step, it takes a toSave dictionary. So here we are saving our model optimizer and our trainer, and it also takes another parameter save handler. So here we can define whether we want to like store this on disk cloud. Here we're saving this on the disk with the help of another handler called disk saver, and we're providing our checkpoint directory to it. And and now we have to attach this checkpoint handler to our trainer so that it saves the checkpoints automatically after every checkpoint every epochs. So on the left side, it is like saving again, like after checkpoint every epoch. So on the right side, we again like attach our handler, and it will be executed after checkpoint every epochs. And finally, we have our for loop. So instead of that, we just do trainer.run, and we saw like a lot of code, redundant code got reduced. It became like more structured, and now you can just plug and play with several handlers, and that's it. Do we have any questions?
There is one question, I think, but it's probably related to another thing, but let's go ahead. So Alonso is asking like if this is compatible with MicroPython on systems like ESP32. I guess this is more related to being able to compile PyTorch.
Exactly.
Itself.
Right.
Actually, more than, but yeah, Victor, go ahead, please.
Well, technically, yeah. So PyTorch-Ignite depends on PyTorch, and it's like the only required. I mean, technically, PyTorch-Ignite helps you to train models, right? So probably you won't train models on this ESP32, right? Probably on this, you'd like to deploy your models and use them for predictions, inference, things like that. Yeah, so technically, basically, if PyTorch is compatible, and if you have enough space, and if you have enough space to run everything on MicroPython, I mean, on this embedded system, so yeah, technically it would work. But does it make sense? I'm not sure.
Thanks. Okay. So
let's
I
go
think
next.
We have, yeah.
Okay,
who's
so
who's going next?
It's me. It's me who continue. but yes, I think we can still keep everyone. But anyway, yes, so I will continue now. So this is the last part of the talk, and it's just about saying what's behind actually this code, and like it's about people right now. So it's a community-driven open source and affiliated to non-focus organization, and technically and basically maintained by volunteers of the PyTorch community. And this is actually the slide where I always like to thank everyone who spent their time and decent time actually spent on the working on this library. So thank you all of the guys. Project also supported by a few companies and organizations, such that actually we can provide some sustainability for the project. Thanks for this organization and companies as well. As for the users of the library, so here we maintain a not unexhausted list of what we could find actually who reference to PyTorch-Ignite. But basically, there's the researchers, R&D engineers doing R&D work, right? So this is more about research and development, and yeah. And we also identified a few blog articles, tutorials, and even one book on deep reinforcement learning using and building with PyTorch-Ignite. There are toolkits, for example, this one, Monai, is about medical healthcare and deep learning with in this domain, which also builds with PyTorch-Ignite for several modules. This one useful for audio processing, and there are many more you can find here. Specific point, as I was already mentioned, so it's about a unique thing for PyTorch-Ignite is our community engagement. So this year we could hopefully run and successfully run a few programs, Google Summer of Code, for example, where we could mentor to great students who contributed to the library and bring a lot of interesting things to it. So thanks to them. We're working with a great tech writer, Priyansi, who is actually with us today in the part of Google Season of Docs, and she's updating our docs and making things more clear, hopefully, right now. We participated since the last year to Oktoberfest, so this year and last year, actually we're in October, so it's still running. We did, and we also plan to do a PyData Global Mentored Sprint. Our community helped us a lot as well for doing other things in addition to PyTorch-Ignite. So our community helped us to build a new website. You can visit it when you have time. And a code generator project, which was built actually by these community members. So actually, yeah, so we open to everyone and welcome everyone to join our community, help us to move forward with this project. And we have some public meetings on Discord. So if you'd like to reach us and ask questions, discuss with maintainers, ask how to start contributing, so please, you're welcome and please join us. And for other news, yeah, stay tuned for upcoming events. Right, so just a few words about Oktoberfest, as we know, in October. So this is event, and actually it's how people can contribute to open source and have some swags in the end. But I mean, it's more about like how to help open source projects, and yeah, PyTorch-Ignite participate with all other related projects to it. So PyTorch-Ignite code generator, we have these repository examples where we can actually store all our examples there, some of the parts of our examples, how it works in practice. So technically you just start at the first, you start reading contributing guidelines to be a bit more aware of how things going behind. Check out the list of issues labeled as help wanted and Oktoberfest. You can comment out that you probably, if you'd like to tackle some of the issue which you think that is not that complicated. And if you have questions, you can ask either on GitHub, on Discord. And this actually will work also for us as well, for this project. So feel free to reach out to us. And yeah, so how to join our community. So as everyone is welcome to contribute and to yeah, so as I was saying, like contributing guides, help wanted issues, GitHub issues were available on GitHub and on Discord. So here are the links. Yeah, so it's almost that. And yeah, so thanks for watching, for listening. And if you have any question, we'll be happy to answer them. Meanwhile, you can follow us on Twitter, Facebook, and Dev2, where we try to bring more events, which what happens with the project. And we have our new website here, where bring the context and examples, tutorials, how-to guides, and all things about the project.
Okay, thanks. Thanks, Victor. Thanks, Priyanshi and Taras for the amazing presentation. I think we have a very shy audience this day. Some of them might not be too familiar with some of the concepts here, but this is also to encourage them to learn more about deep learning, which is a really interesting field that is really changing the world. There was someone asking about links about the examples. You can see, we can share the presentation link that has all the links to everything.
Yeah, sure.
So let me share that again, just in case. So there we go. Okay, cool. So I guess I have a couple of questions of my own, and it would be like, usually Hacktoberfest, like, so maybe people are not familiar with Hacktoberfest that much. So what are the perks that, or what is the things that usually, a lot of people, well, Hacktoberfest is just this period during October where people are encouraged to contribute to projects, open source, all around the world and hack around in different things. But usually it comes with some strings attached, like you get some token of appreciation for doing it during this time or something. So I am just wondering if that's also the case for this project and what that is, just to know a little bit more.
Yeah, so basically I would say that I'm not sure actually how they do this year, but previously it was something like if you accomplish this Hacktoberfest with merging like 4 or 5 PRs, right? So you'll have a t-shirt and some stickers and some other swags. And yeah, so basically this year they try to have sort of equilibrium where they you have some meaningful contributions and not only guys who would like to get only the t-shirt. And yeah, so in our case, yeah, so we make our project available for these contributions, and the guys merging things, even if they not yet merged, but we can label them if they can make sense to, like, you know, the Hacktoberfest accepted, and it can follow all the rules that Hacktoberfest provides. By our project, actually, so we have for this, well, distinguished PRs, so for those who can accomplish them, so we can also send our stickers.
Okay.
Stickers to to send as well.
That is great. How old is PyTorch-Ignite? And I guess the other question that will follow on that is, what are the next steps for PyTorch-Ignite with respect to new features that PyTorch is implementing or new features that PyTorch-Ignite itself wants to provide?
It was started in like end of 2017. Yeah, it was like, I mean, it's community driven. So I mean, the team, like this time, the team is like probably I'm the the oldest one. We renew the team, and like in the beginning there was few people. Actually, one was a created guy who created the project. Then I joined also the project, and there were a few other guys who contributed and left. And you know, this it's open source driven community project. And as a roadmap, we have few ideas actually. Our roadmap is available on, you know, the wiki of the GitHub, where we'd like to refactor engine, provide more integration examples, and actually keeping our library in this way that we don't need to recode more things to support newer hardware or whatever things, but just staying in the way that we do not block users to use these other technologies. And this is the main point of the library itself. And as for other probably a side project for Ignite is we like to provide more tools around, like for self-supervised learning, for example, using Ignite, and have something like code generator, but another toolkit using PyTorch-Ignite to do these things.
Okay, that is great. So how big is the project in terms of contributors or active contributors or core developers at the moment? I guess I can go to GitHub and kind of answer that question myself, but I just want to to get an idea of the size of the project in right now.
I would like to answer this question.
Maybe Prashanti or Taras want to answer these questions. Yes.
Yeah.
So I guess I can go. We have over, last I checked, 3,700 plus stars on our repository in terms of co-developers. So there's Victor, there's Taras, there's Sylvan, he couldn't join us today. There's also Francois, and I hope I'm not missing anyone out.
There's Ahmed also, he's helping.
Yes, there's Ahmed also. Yeah, and I was gonna mention that he joined through via Google season of code, and he's been helping a lot with the repository. On our Discord, we have around 100 members, and we have our public meetings, and we get people join, and we have a lot of questions. So I guess that would answer this question. Yeah.
So one thing that I noticed is PyTorch-Ignite is a project that is pure Python, or mostly pure Python, but PyTorch itself, it's a binding to the Torch library, which I believe it's written in C++. So I'm wondering if having this extra layer of simplification that PyTorch-Ignite produces, does that have an impact on the performance in general of how fast the model runs, or is there a noticeable effect, and any advice on how to deal with this to balance this out maybe?
Well, technically PyTorch-Ignite is thing wrapper on loop, training loop. I wouldn't expect that there is much overhead on that. But the extra calling functions, they still bring you overhead at probably microseconds, milliseconds,
Okay, but in theory, there should not be a big overhead. Most of
Right.
the heavy lifting is already going to be handled by the C++ code anyway.
Well, in terms of, if you're training models and it takes several hours, so probably if you have 1 second or 2 seconds overhead is not that noticeable.
Okay, great. Thanks a lot. So I don't know if there's anyone else in our audience that would like to share any thoughts or have any particular questions on this project. Let's see if someone jumps up.
I like the question actually. So on this drawbacks of the flexibility, and so probably maybe can go more on that. So PyTorch-Ignite is not the single project actually doing these things like that. So basically, if I go to another side of the things, like if you have a, in the very beginning of this hype of deep learning, you had this Cafe framework was, which now it's not. I mean, it's not maintained anymore. Almost. There is TensorFlow, and there was this wrapper as Keras, which provided this sort of simplification of doing the training, things like that. And the point is that TensorFlow, on the other hand, is similar as we explained here. So PyTorch is low level for these specific tasks, and TensorFlow is great to create your pipelines of how you do your model. I mean, you pipeline the model, how you do the training, and they provided a bunch of stuff actually, which can be sort of also simplified. And the Keras was one of the, I mean, it's still a very well known project, and which simplifies the training. And the point is that they're actually they try to simplify everything in a single line, or 3-4 10 lines maybe maximum that you have. If you have some specific tasks, then Keras probably will be a limitation for you. And then you try to probably go to how they do the loop, how you extract some information that is sort of hidden there. And by the design, you can have still some probably limitation, I would say, in this case. Ignite on this case, I mean, if I do the parallel, so I would compare Keras and Ignite in this, because they do not do this well. They still try to make these abstractions of the training loops, but not the same way. And in our case, we'd like to probably not hide everything, but just to simplify things that are common, but still make you make possible, I would say, hard things to do, hard things possible.
Okay. So it's a kind of in between approach. So it doesn't make it so simple that you're still limited to do more
you
tailored
more to make more code, yeah, but still some common parts, like, you don't have to write your metrics if you have like basic things. You don't have to write the same logic for early stopping, checkpointing, saving the best model, things like that. So actually we try to explain. And plus, in addition, you have your training loop, which can be really highly customizable. So you have like, basically you just loop over the data, you apply some model updates and things like that. And then like in PyTorch or wherever other projects, what they do, they use this concept of software engineering callbacks, where you have these sort of predefined events and you have these abstractions where you can derive from a callback and put your own logic into the training loop. In our case, we do not require user to derive from some abstraction. Just you have a function, just put it there. I mean, attach it to the trainer, it will run. So the scheduling of the custom logic is more simple, I would say, in this way. Plus filtering.
Are there any other projects that are trying to do the same as PyTorch-Ignite, but are?
Yes.
Yeah.
Yes.
Okay. So can you just share some names so that people also know? I mean, it's the competition, but it's open source, so we're all friends here.
Well, we're not all friends there, but this is the point. So I mean, there are cases that you can have like community-driven projects, and then you can have like company-backed projects. You can have other projects, and then it's. But there are great projects, I would say, like, for example, Catalyst, which also providing things like, like Ignite, I would say. There are others also.
So there is a comment here from someone, I'm not sure how to pronounce that, but so, well, it's a comment, so I just wanted to share. So I'm very new to machine learning. For now, I've been using Keras. Looking at Ignite, it seems a bit difficult to me for now. Probably just I'm going to use in the basics. And thanks for your explanation. I think this ties to what you just said. Like, well, PyTorch is based on PyTorch-Ignite is based on PyTorch, so you already will need to learn about that before jumping into Ignite.
Yeah, I would say this is great feedback for us, and the way how we actually can make our tutorials. So yeah, please visit our tutorials and please visit our site and try to follow actually what we're doing in the getting started thing. So if it's still unclear, please shoot us an issue and say that probably where we can make the project better. Yeah, but I agree that the difference between like when you go from Keras to this can be difficult in the first moment. Then you can, if you understand the API, how it works, probably you can appreciate what we bring.
Absolutely. Okay, I think we're 5 minutes from our defined finish time. So I think we can wrap it up here. Again, thanks, Victor. Thanks, Priyanshi and Taras, for your time and wanting to share the knowledge of this awesome project that I have not personally used, but I will be using in the upcoming months as I'm delving myself more into deep learning as part of my
right. So
education.
once you get started with the machine learning. Yeah, thanks a lot, Gonzalo, yes, for actually the invitation and inviting us to share this, share about our projects. It was really cool, and yeah, thanks a lot.
So remember, like, follow us on all the networks, on Twitter, on Facebook, on Instagram, on LinkedIn. Python Bucaramanga is part of a larger community that is Python Colombia. And of course, you're all welcome to come and contribute with talks. We're doing these international talks once per month, and we're doing the more national talks like also once per month. So we're doing 2 talks per month. It has been a bit challenging, but it's something that we're really enjoying, and it gives us the opportunity to talk and work with awesome folks all around the world, and also expose the Colombian Python community and technology community to the different things that all of you are doing. And remember, like, contributing to open source is not just about codes. A lot of time that's like one of the biggest hurdles and limitations that I've personally heard is like people tell me I don't feel confident enough with my coding skills, and that probably will follow you until very late in life. I still do not feel confident with my coding skills, but at this time you just learn to fake it. So that's the secret. But of course, there is not only code, and this is something that I would like to take the time, this little time we have left, to emphasize that open source is about documentation, it's about creating community, it's about creating engaging content, it's about creating tutorials, it's about answering issues and creating issues and helping organize all these issues and replying on peers, and hopefully try to be nice and gentle with people that are just starting with open source. And a lot of this work may or may not require to actually have coding skills, but just requires you to be motivated enough to help in a project that is clearly making a difference and helping a bunch of people all over the world to train their models faster and in a more efficient way. So I would like to make a shout out for you and the whole PyTorch-Ignite team, of course. And hopefully you can feel this is a cool project for you to contribute in, and I will invite you to go there. So thanks again. Thanks, Mafe, for helping organize this community as usual. And thanks again to all of you, the audience, for joining us today. And we'll
thanks
see
a lot,
you.
Gonzalo, Mafe.
And I don't know, maybe we'll see each other soon. We'll see how it goes.
Sure. Thanks a
Okay.
lot. Thanks a
Thanks
lot.
Take care,
a lot.
everyone.
Yes.
Thanks.
Bye-bye.
Bye.
Thanks. Bye.